Well, I decided this morning I'm going to investigate whether or not this old DRO that was on the Wells Index parts machine that I bought, whether or not it has any life left to it, and whether or not I'll be able to install it on my machine. So I guess the first thing I'll do is I'll just give it a quick cleaning on the outside. The cord's obviously bad, but it's not completely severed, so probably just going to plug it in to see if it powers up, and then if it powers up, then that's a good sign, and then it'll be worth. I don't want to go through the trouble of replacing the cord only to find out that this thing's completely junk. So for starters, just give it a good cleaning on the outside. Actually cleaned up pretty decent. There's crud on the bottom here that's pretty much baked on. Ugh. Oh, we're talking old school here. These big chips. These are what is known as dual inline package, DIP, integrated circuits. No surface mount technology here. This is all old school PC board. This is a 1980s vintage DRO. Kind of neat to see the way they did it back then. All of these integrated circuits are mounted in sockets, and then the sockets are soldered to the PC board. So if you get a bad chip, you can pop out one chip and put in the replacement chip without having to do any soldering. The bad part about that is that where the chips plug into the sockets can actually develop into a bad connection. I'm just giving a little light push to these to see if they're all seated. Sometimes they can creep out of their sockets over time. And there's a toggle, not a toggle switch, there's a little switch right there on the PC board. It's interesting, there's no hole in the cover to access that. You have to take the cover off to switch that switch, so obviously not something you need to access very often. Wow, there's a big filter capacitor in there. Can't quite see the value on it. Oh yeah, you can. Let's see. 12,000 microfarad at 40 volts DC. That's probably like a computer grade cap. So this is a what you call a brute force power supply inside here running this thing. All you've got is a transformer. And that's going to be rectified by probably a bridge rectifier somewhere. Secondary of the transformer. Oh, there it is. Shake the crud out of this thing. Kind of hidden, but mounted to this heatsink right down here. These four leads. That's a bridge rectifier. So that's taking the AC from the secondary of the transformer. The AC comes in, goes through a switch, and it goes through whatever this device is over here. Might be some sort of RF filter. And then it comes onto this board. It's rectified here by this bridge rectifier. And it goes through, and then it's filtered by this filter capacitor. And then it is regulated by, looks like we've got a regulator transistor mounted outboard on this heatsink. on the back here. So underneath this plastic cover there's a regulator transistor. There's another integrated circuit of some type. Sorry, a semiconductor of some type there. Might also be another regulator. But it looks like all of this power supply does is create one voltage that comes up through this black and white lead right here to the main board. So then you've got some more semiconductors on heat sinks right here, and this might be more power supply here where you've got some regulation going on and changing of that one DC voltage into multiple DC voltages, because you've probably got a couple of DC voltages needed to run this thing, because you're going to more than likely you're going to have a 5-volt supply for the digital logic circuits, and then you're probably going to have a higher voltage needed to drive the LED readouts, as opposed to LCD. This uses LED, light emitting diodes. So the main issue with this that was evident right from the get-go was the fact that one of the cords going to one of the two scales had been ripped out. And it turns out the good news is that the way these plugs actually plug into the board is basically you've got the contacts right here on the PC board, on the edge of the PC board, and these plugs are actually made to push onto that, and then they're retained by these two thumb screws right here. So if we take the thumb screws off, we can actually slide this right off, and then it's marked right there up with an arrow, because you could inadvertently put this on completely wrong, apparently, except for the fact that the holes don't line up also, so that actually stops you from doing it the wrong way. And then I imagine you can interchange them. Yeah, you could, and the only difference was X would become Y and Y would become X. So other than that, these two circuits are pretty much going to be identical. So for the time being, I guess we'll leave that on there, and we'll power this up and see if anything happens. Alright, this appears to be the on-off switch, although it's just got low voltage wiring attached to the front PC board, so in retrospect I think this is just a display on-off switch. In other words, you could probably leave the DRO on and it would retain whatever the settings are, and you could shut the display off. In addition, there's a switch here that says keyboard on or off. Now, I don't know whether or not they meant keypad, but it's BD, so that's keyboard. This might just be something you could shut off so that you can't inadvertently hit the buttons when you don't want to. Well, we'll leave it off for a moment and see what happens. We have datum, D-A-T-U-M, datum, and step. And then this one is millimeters and inches. So that's self-explanatory. This we think we know what it does. This we think we know what it does. Datum and step. Couldn't tell you. Maybe somebody has one of these who just knows what that means. Alright, so on the back, we have a main power. That's an interesting switch. Let me show you this switch on the back here. It's an interesting style. So this is a main power switch here. It says push on, and then to shut it off there's this little red trip lever here. You push it and it's almost like a circuit breaker the way it trips. So that's interesting. I guess this makes it easier if you're reaching around the back of the machine and you're fumbling back there, you can hit it easier, but well, I don't know. Okay, so we're going to leave that off, and I'm going to plug this in. because that cord is so bad, it may just trip my circuit breaker right off the bat. Power it up. Oh yeah, that's not good. Yeah, this looks like it might be a very sick puppy, because it's not completely dead, because we've got something lighting up over here, but we've got no... Well, that's actually interesting. I have this off. And it's doing nothing. None of these buttons are doing anything. Oh, well, the millimeter inch button is making the little decimal move. That's about it. So the X is completely out, and the Y is just showing a negative sign. I mean, I doubt that it's because the scales aren't hooked up to it. I would have expected this thing to power up and just show me a display, and it doesn't. That's a shame. And I'll plug a scale in, just for giggles. Alright, so now I plugged in the scale that has the broken connector on it. Yep, one sick puppy. Well, what I did was I took my digital voltmeter and I measured the voltage coming from the main power supply up to this board here, and discovered it's just a regular 12 volt regulated supply. So since it's 12 volt regulated, I figured, well, I'll sub it, disconnect this plug, and substitute with my 12 volt B&K Precision power supply over here on the bench. And the reason why I did that was because I know that the 12 volts is there, but what I don't know is whether or not there's any AC ripple, which could be causing a problem. No, that was just a shot in the dark, hopeful. You know, if you get an audio circuit and you have AC hum, you know you've got a bad filter capacitor. The only way I could really determine if that filter capacitor was bad would be to put an oscilloscope on it and look for the 60 cycle waveform. So, just for the heck of it, I figured, well, I know I've got a known good 12 volt source that's clean. Let me feed that to it instead and see what happens. And unfortunately, it does the same exact thing. So all that tells me is that my problem is not the power supply. This doesn't guarantee that I don't have an additional problem with the power supply. Power supply seems to be putting out 12 volts, and I don't think the AC hum would be an issue because it's dead either way. So I've got something else going on up here. I think maybe I'll take that board out, take a look at the backside, and see if I can't see anything obvious along the lines of solder connections, which would be nice, but I don't think I'm going to be that lucky. So I just removed what I believe to be all the screws holding this in. 3 in the back here, 2 in the front. There's one that I took out there, had a little plastic washer, and this one right here also has a plastic washer. I unscrewed it, but I can't. There we go, I got it. What's that plastic washer is going to fall out? Well, I can get that later. And then, oddly enough, a completely different screw over here. These are all Phillips head. And this one way out here on this large standoff that goes all the way down to the bottom is a much smaller one. Alright, and then we've got these almost like a ribbon cable arrangement here. They don't appear to unplug. So, I don't know if for service, if you're just supposed to flip this sucker over. Alright, where'd that plastic washer go? Wow, look at the corrosion. Actually, there's some discoloration on the board here. It almost looks like something was sprayed in there, chemical of some type. This is interesting how this is all. The epoxy on this foil is all lifted. For those of you who don't know about circuit boards, printed circuit boards, I'll just show you real quick. Printed circuit board basically takes the place of a bunch of individual wires going everywhere into connecting all of these semiconductors. So what they do is they start out with a board, and it's got a thin layer of copper cladding on the whole board. And then what they do is they etch out, through a process, they etch out areas where they do not want electricity to flow, and they leave behind little runs of copper. So wherever you see this light green color here, that's all copper that was left behind. So you can see, like right here, all of these little lines up here, these are all acting as wires connecting that point to that point. And then some of these PC boards are, like this one, are what are called double-sided. So they've also got them on the top. And then they have little connections that actually act holes that they flow solder through that act as what they call a feed-through to connect the connection on the top to the connection on the bottom. So this is a double-sided board. The reason why this is light green in color is because they spray the whole board after they're done with a chemical. I think it's actually an epoxy, if I recall correctly. But anyways, normally you don't see it wrinkling and lifting like this, which makes me wonder whether or not this has gotten, if something had gotten to this over the years. I don't know. Well, I'll look under magnification at some of these connections and see whether or not I could see anything obvious. If I could see an obvious bad connection, I could resolder it and maybe be back in business, but I don't think so. I don't think I'm going to be that lucky. Well, in lieu of the lack of a schematic diagram, there isn't very much I can do to troubleshoot this thing. I checked the continuity on these front panel switches. They're all good. So it's not something simple like dirty contacts on a switch. And I've got those 4 semiconductors on heat sinks here, and I was able to determine that this large trace right here is the ground. The center pin on this semiconductor and this semiconductor are both tied to ground, and one pin has 12 volts going in and the other one has 5 volts going out on both of these. So my theory there is that these are both 5-volt regulator ICs that take 12 volts in and feed 5 volts out. So I get 5 volts here, 5 volts there. That would indicate those two are working correctly. And the two over here near the back, they also have 12 volts going in. They have about 4.9 volts going out, so a little bit lower. But again, appear to be working. If there was a major short, they would probably already have been damaged. And I felt the IC chips after it was running for a little while, and I didn't feel any of the IC chips getting unusually hot, which would indicate an internal short in one of the chips. So the last thing I think I'm going to try and do before I pretty much give up on this thing is I'm going to shut the power off, and I'm going to pull out each IC chip one at a time and reseat it. And the only reason I'm going to do that is it could be that there's corrosion on the legs of the ICs causing bad connections, and just the act of pulling them out and putting them in might rub enough corrosion off to start making some connections. So if I see any improvement at all by doing that, then I might be willing to go the next step of pulling the ICs out, cleaning all of the pins, and putting it back in. If that doesn't make any difference, though, then I'm just going to cut my losses. Well, that does it. I'm going to have to give up, at least for now. I'll poke around on the internet and see if I can't find a schematic online for this. One that I could just view online for free. But I wouldn't even bother buying if I find one that I have to buy, I wouldn't even bother buying it, because chances are I'm going to run into a situation where I end up sinking more money into this thing than it's worth. The only thing I did notice was these two ICs are identical, and the way that the runs from these ICs tend to go over to these resistors and go over to these ribbon cables, which go over to the front LED readout, I think these two are the LED drivers. And since they're identical, just for giggles, I switch them. And when I switch them, the decimal point that was the only thing that was lighting up in one moved to the other, but the negative sign in one stayed the same. So it might be something as simple as both of these chips right here being bad. But again, you know, without a schematic and being able to do some further checks, it's kind of hard to verify. And even if I could find these chips, they'd have to be dirt cheap for me to chance buying them just to find out that, you know, that isn't the issue, or that if it fixes the issue in the LEDs, you know, the display lights, that there's some other problem. So I'm going to have to call this quits for now.